If you're a software tester in the telecom world, you definitely know that feeling, staring at a bug that just makes zero sense. Well, today we're going to give you the mental map you need to solve those mysteries. We're breaking down telecom network architecture, but from a tester's point of view. Let's dive in. Have you ever found yourself just staring at a bug report wondering, why here but not over there? You know the one, a feature works perfectly in one city but completely fails in another. It's fine on 4G but breaks on 5G. It is a classic, and let's be honest, a really frustrating problem in telecom testing. But what if you had a map to make sense of it all? Well, that map is the network architecture. And understanding it is absolutely the key to triaging defects faster, cutting down on confusion, and being able to speak with real confidence to developers and architects. The good news is, you don't need to memorize every single complex diagram out there, you just need a clear mental model. And that's exactly what we're going to build today. To get started, we're going to break this whole thing down into 3 simple, manageable parts. And the best way to do that is with a really relatable analogy that just makes everything click into place. I want you to think of a telecom network just like a city. First, you have the access network. Think of these as your local streets, how you get on the road. Then you have the core network. This is the city's main highway system and all its traffic control. And the transport network? Well, those are the massive interstates connecting all the different cities together. Simple, right? Okay, so now let's take a guided tour and see how the city map helps us find bugs in the real world. So let's walk through each of these layers, but we're always going to look at it from our perspective as testers. The goal here is to figure out how to pinpoint where a problem is most likely hiding. First up, we're on the local streets, the access network. This is the entry point for literally everyone. It's the cell tower your phone is talking to, or the modem that brings broadband into someone's home. It's all about getting that first connection. So, what kind of bugs live in this neighborhood? You guessed it, call drops, that dreaded no service message, a weak or spotty data connection. These are classic access network issues. And here is the absolute key takeaway for testers. These problems almost always get blamed on the app, but the real root cause is often right here, at the very edge of the network. All right, next you're heading downtown to the city's traffic control center, the core network. This place is the brain of the whole operation. It's where the network decides if you're a valid user, where to send your call, and what services you're allowed to use. It also connects to all those important back-end systems for billing and support, what we call the OSS and BSS. Now, bugs in the core network are a bit trickier. Think about a call that just never connects, or a login that keeps failing, or maybe a service that's just acting weird. These are tough to diagnose because it's not a simple crash. It's a breakdown in the system's logic. And finally, we're hitting the open road on the interstates that connect our cities, the transport network. This is the super fast data highway, usually built with fiber optics. Its one and only job is to move huge amounts of data, quickly and reliably, between all the other parts of the network. It's all about speed and capacity. This is exactly where performance issues tend to live. So if you're seeing high latency, really slow downloads, or timeouts when the system is under a heavy load, you should start thinking about the transport network. This is also why performance can change so much depending on where a user is, or even what time of day it is. Okay, so you have the basic map. Now let's add 2 more layers of detail that will turn you into a diagnostic pro. Seriously, these concepts will help you pinpoint issues with surgical precision. First up, the control plane versus the data plane. The control plane is what sets everything up. It's the signaling that says, let's start a call. The data plane is what carries the actual data, your voice, the video you're streaming. This distinction is so important because you might see a service connect perfectly, meaning the control plane is working fine, but then the quality is terrible, which points straight to a data plane issue. Next is getting the difference between logical and physical architecture. You know, as testers, we mostly see the logical view, that nice, neat flowchart of how systems are supposed to interact. But the physical architecture, the actual servers sitting in a specific data center, that's what explains those real-world problems, like why there's more latency on one coast than the other, or why a failure only impacts users in one specific region. So, why does all this matter? I mean, really, why? Because knowing this stuff doesn't just make you better at finding bugs. It fundamentally changes your role and your impact on the entire project. Let's look at how. Without this map, it is so easy to fall into the usual traps. We blame every single bug on the application code. We ignore those weird location-based issues as anomalies. And we end up writing vague bug reports because, frankly, we just don't have the context to do better.
But with this knowledge, your approach does a complete 180. You can start a bug report by suggesting the likely network layer involved. You can describe the conditions with incredible precision. You start asking developers much smarter questions. And you stop being just a bug reporter and you become a real problem solver.
And that really brings us to the most important point of all. Understanding architecture is how you make the leap from being a test executor, someone who just follows scripts, to a true test analyst. It's how you earn the trust of developers and architects and how you become an invaluable member of the team. So please remember, a telecom network is not some mysterious black box. It's a city with local streets, big highways, and interstates. By understanding the access, core, and transport layers, you now have the map to navigate this world with clarity and with a whole lot more confidence. If you found this helpful, please like the video and subscribe to Enhance Smart Skills for more simplified telecom and testing concepts. Thanks for watching.